it was just the simplest possible smart contract. So it was basically learning the environment, how to set everything up, working through the Hello World tutorial of just having the simplest possible smart contract, which is the storage contract. It holds a number. You can store it, and you can write it, you can read it. And yeah, I want to continue the journey from here. So last time it took me like 2 hours to set the whole environment up, figure out that it's not really lovely to do this in Windows. So I have to work with my Linux subsystem in Windows. Maybe I'm gonna boot up my Linux distribution at some point, but typically I don't need it. And yeah, but maybe it makes more sense here. And I'm also not too much of a Mac guy. So what I'm doing when I'm learning is I'm putting everything down in Figma and conceptualize it. And so these are the links that I gathered last time. So I have some learning resources here. This is basically all the links that I gathered. So everything from the Polkadot docs. Is this maybe the ideas that I was looking for? Yeah, basically just so that I can keep all the links, a few SDKs. Then I have here links for how to use a chain. So I see some front-end libraries, I see some SDKs to talk with a chain, and then how to work with a chain, Chopstick, Simnode, ZombieNet. Yeah, so basically this is my exploration here, how to do smart contracts, and I have a section for Solidity and Ink. And now this is new, you didn't see this last time, but these are some ideas that I have been capturing through the last few days about what kind of interesting things I could build that would be fun to me, or that might be interesting. I'm also never shy to use Claude or Claude Code or any other AI to help me do this. Yeah, so this is where we're starting off today, and I also want to show how I'm diving into new topics. So we have set up the basic infrastructure to build. Let's see what I will remember. And so I think what always makes it interesting to build something is to have an understanding of what to look into, or have something that motivates you to look into and build. So what do I have here? I have some payment ideas like social tipping, Patreon for the creator economy, DCA savings tool, something like Splitswise. I got this idea of building an escrow. Then gambling, like poker, would be an interesting problem to solve. You need randomness, and then you would, this is a very hard problem actually, but I think we got all the primitives to do it. Yeah, casino games, because it's very numerical, and it's interesting because you maybe need random numbers and so on. Chess, trading card games, and then society building tools like UBI. Maybe UBI smart contract would be fun. A form that would actually be fun, and you can get traditional crypto people triggered because you should not store chat messages on a globally distributed ledger. News aggregator would actually be fun. Linktree. Then what do we have here? Of course, prediction markets, OnlyFriends, marketplace integrations. Yeah, so starting with one of these, and then of course also understanding that the skill set is yet limited. And so you have to start at a simple point. There is a Christmas button in my Restream software. Oh, it's music. Can we add music? Yeah, maybe not. Good. So, okay, I'm gonna flag the ones that look interesting to me and sort of maybe doable. So I see these two, they look interesting. Trading card game, I tried myself at that, like it's still a little bit too much, like Simpler would be better. Social tipping might be fun, but you need a proper front end to make this work. Patreon would actually be interesting. Patreon would be interesting. And then an escrow would be a very simple thing to get started with also. So these are the things that I'm looking at. And then, of course, one thing that you should learn at some point is to just build NFTs. NFTs just to get used to a certain token standard. Yeah, maybe creating your own token. So what are these standards like tokens? So these are ERC20, this is ERC 721, I believe, and then it's ERC 11, what is it, 1122, 1188? What is the mixed standard? Token standard 1155. So maybe looking into these standards would be actually the right thing to do as a starting thing. And then also, I think what I should learn is it Foundry? Is it hard? It's not Foundry, it's Hardhead. Remix. I think looking into Remix might actually also be good for the learning journey. So it's because it's sort of, it's sort of the building blocks you want to build on. Is first thing I learned is a storage contract, which is just how do you store data, how do you read and write it. So tokens would be fun. Maybe we can combine the idea of having a universal basic income token with just like a token in ERC20 that looks like it would be simple enough for a starter. And still an interesting challenge, especially how to trigger the UBI, like the payouts based on time might be an interesting problem. And it also highlights a little bit what is the cost. And then there is also a question that I was wondering about, which had to do with the forum or a news aggregator. So let's say news or chat or mailbox. And then the question that I have here is, what is the gas cost of storing a string on chain? So this is sort of like a little bit of a technical question, but that's still a very basic question. It's interesting me. So gas cost, right? Or how expensive is storage on the chain truly? And that would be interesting for Paseo, that would be interesting for Kusama and Polkadot. So that might be something to look into. So I would say it's either creating a token or storing information on chain. And I would say that the storing information on chain is simpler. What's going on here? How does this work? Okay. So maybe I will just do that. And before I get started, I'm going to check out if there's some comments on Twitter. Nope. Okay, so I feel like a token would be a bit boring, and this is more technical. But this is interesting to me right now. Yeah, and I also should get better with the tooling, and I need to figure out Remix where it is, because Remix is, there is a Remix instance, I think. Let me ask Claude maybe. Where can I find the Polkadot Remix instance on the web? Good. Yeah, and then, so I would say that is the direction we're going on for today. The docs website changed a bit. Tutorials, Parachain, smart contracts, deploy an NFT, deploy an ERC20, launch a first project. I think this is the thing I was doing. demo applications, Uniswap version 2, Hardhat. Yeah, that's just deploying a full application, but I would rather go low level first. And I believe I have the URL for Remix. Okay, so what do we have here? This Remix. This looks like it is, I don't know what's the name of the framework, but this basically looks like Visual Studio Code. Yeah, this looks like Visual Studio Code crafted to be good for smart contracts. And it's deployed on Polkadot.io. So let's look at that. What happens if I click Start Coding? Okay, so don't know if I need to make this bigger. Yeah, making it a bit bigger helps. So if you click on Start Coding, you get some examples. This is the storage contract we already have. I remember now. Last time I was coding, I was actually very engaged in deploying my own local node. And so what would be actually interesting this time is to deploy on-chain, but I'm gonna add this to my stack of skills that I've built, which is running my own node. So running my own local substrate EVM node. And we have a storage contract, right? So this was session 1. And we're in session 2 now. So Medium, this was session 1. And then for session 2, we are going to look into Remix. We are going to looking deploying, let's say, live into a live network. And then, which of the two is it? Not sure how feasible it is to do like a mailbox or chat. But anyways, we will just try. We will just try what happens and see. So, okay, we have the storage contract. Owner. Event owner is owner. So I guess this has to do with the owner of a smart contract and maybe controlling the owner. So constructor, I suppose, is called upon contract creation time. So upon contract creation time, estimated gas cost. Yeah, what is the estimated gas cost? We don't know. I guess it's not estimating it properly. Okay, but this is nice if it works. Okay, owner contract deployed by message sender, and then it sets the owner property, and it emits an event. Change owner. So actually, while we are at it, are there EVM explorers for Paseo, Western, Kusama, Polkadot? What are the actual block explorers for these chains? Do I find this on the page here? Was it tooling? Was it tooling section? Deploy an NFT. Let's just see what it says here. Open Zeppelin, Remix ID, MetaMask. Okay, I guess I need to make sure that MetaMask is in a status where I can actually use it without compromising my keys here. Oh yeah. Yeah, I feel like this was the account I was using. Okay, so I have MetaMask ready. Pass. Okay, connect your wallet section. So maybe I'm gonna do that. Wallets for Polkadot Hub. Connect your wallet MetaMask extension. Okay, and we want to connect to Polkadot Hub testnet, which I guess is the Pasir one. So I'm following the instructions here on the side. I'm clicking here, view all. I'm checking out the networks. And there is no button to add a custom network. Maybe I have to activate the developer mode or something. Networks. Okay. Add a custom network. So, okay. Polkadot Hub testnet. And then the URL is, I have to, okay. So this is the chain ID for 20, for 20, for 22. The currency symbol is pass. And then the block explorer URL is this one. Whoops. And then the RPC URL is this one. Oops. So, okay, and this also gives me a block explorer. So let's see if that one is live. Yes. Sweet. Contract call. Is this just happening right now? When did this happen? 2 minutes ago. Okay, so there's contract calls going on already. 2 minutes ago, 6 minutes ago, 10 minutes ago. So someone is doing smart contract calls every 4 minutes. Cool. What's the smart contract doing? Okay, that's very affordable fees. Confirmed within 6 seconds. Logs, data. Okay. So we're not told what is happening here. Okay, whatever. I guess good. good. And then gas, this is not Y, this is Psi, Gypsy, GigaPsi. Fast, normal. Yeah, okay, anyways. Okay, let me store this. And I added my network here, which is good. What other networks do we have? Polkadot. That's it. Okay, so I suppose now that I have connected, I should actually fund it with some tokens. So we're gonna go to the faucet. Check out the test tokens section, faucet. Good. What's the address that I'm giving? Okay. And is it an EVM address? Yeah, it's an EVM address. Good. So account. Where's my address? Adressen. Okay, I have my address. So send it. Pass it hub. Smart contracts. Looks good. I'm not a robot. Good. Claims that I have some tokens. So I guess I will need to wait. Maybe I need to select the right network. I've added it, but I also need to change to it. Bang. How can I? Not used to. I'm not used to. How do I select the network? Networks. How do I switch to that network? No. We gotta figure it out. Give me a second. Polkadot hub network. Oh my God. Click to switch the network. Select the network. Okay, this is manage networks. Add network, save. Select the network. I feel so stupid for not being able to select the network in MetaMask. Oh, I can move it. Oh my God. Account. Ah, it's already there. Tokens. Pass. 10,000. Ooh. Faucet is giving 10,000 now. Good. Good. Okay. So I have that. Test tokens. Okay, now I'm in Remix. Create the contract. Okay, I have a file and then compile the contract. So did the compiler compile? And then deploy is below here. From the environment, I select the provider. Okay, let's just see. So okay, so what do I want to do actually? What is it? Well, let's check out the other contract and then we can see. So the owner contract, I can change the owner, so I can make someone else the owner. And then what is a ballot? It's a vote process along with vote delegation. Interesting. Okay, so I have a contract with a ballot. There is a voter with a weight. The person is voted or not. So this is a single ballot with a delegate. So I can delegate to a person. This is what I'm receiving, I guess. I see. So this is a vote. This is a per vote. Okay. And then a proposal has a name and a vote count. I see. So this is just for a chairperson. Is this like an owner? Okay, so we have a contract with a for loop. I hear they're seen very critical in crypto. So chairperson has a weight of 1. Okay. Blah, blah. I would say I want to try to deploy the storage contract and then just play with that. And then we have scripts here to deploy. Let's see. Deploy over free. It's the same code, just a different library. I see. And then tests for the ballot. Okay. So I want to deploy the storage contract. Solidity compiler. Compile. Okay. I guess that's a success. Good. And then provider. So because it runs in the browser. I can actually connect my wallet here. Interesting. So no storage. Compile. Okay, we have it compiled. Look. Select it here. No provider pinned. What does it mean? Do I need to? Okay, let me check the instructions again. So compile the contract. Compile. So deploy from the environment injected provider talisman. Or check deploy of the Remix IDE to get more. Injected provider MetaMask. Good, so. Okay, it's not injected. Do I need to connect the wallet somehow? Home. Customize this list. Okay. Has been added. Very good. Injected provider. Very good. You are allowed to connect. Good. Let's see. 0 Ether. But I have pass. So I guess I'm happy. 0 Ether. It's not very convincing. Is it the right address? That's the right address. Okay. So I'm just going to try. Now it knows the value. Okay, very good. I have 10,000 Ether. Estimated gas. So there's how much gas I'm willing to pay. Look, and it changes according to whatever file I've opened. Okay. Storage. Deploy. Cool. So asks me to deploy. It tells me the amount in dollars, but not in pass. I don't like this, but okay. So I guess it's in a block. So let's check, where's our block explorer? One of these. Contract creation. This is me, and I created a contract. Cool. Very cool. Very cool. 1000 GPC. Okay, cool. Yeah, so deploy the smart contract. Check. I can't put a check to that. I can save this as a scenario. That is cool. Like a recorded macro. Good. So I can use the contract now, I guess. Okay, this is how to manage networks. Don't need that anymore. Don't need the faucet. So create a new contract, compile the contract, deploy the contract, blah, blah, blah. Once your contract is deployed, you will see it interacting with the contract. Yeah, so I see it not, so this is deployed, but it's not pinned, so let me pin it. It's the storage contract. Oh, nice. Retrieve. Okay, so the value is 0, and I can store a value now. Store. Nice, but a bit annoying if I have to sign every time. Stroop. Very nice. So when I retrieve it, it's 42. Sweet. And if I check out my transactions here, contract creation, transaction, Y 2 times. But I just created one contract. 3 weeks ago. Did I create the contract on chain? I cannot remember. Good. Okay, so I created a contract just now and interacted with it. It's possible that I think I leaked a key for this wallet, but I don't think anyone would use it. I guess it was me. Okay, this is a testnet transaction only. So what do we see? I mean, it's a contract call, so node's position. This might be the index. This might be an index, and this is here. I guess we cannot read this as long as I've not uploaded some metadata. State. And the contract, is this the contract? It ends on 28210. Okay, so this is the contract. Okay, so this is the interface. Verify and publish. Can I publish my source code here? Aha, can I do this from Remix? No. Solidity single file. Is your contract? I don't know, man. Compile. Why do I? Yeah, okay. Let's skip that for now. So interacting with contract. So I've pinned the contract and I have this interface here so I can interact with it. Good. So it would, of course, be interesting. Okay, you know what? I'm going to add this to my roadmap, to my learning roadmap, is OpenZeppelin. Okay, but so okay, what I want to learn now is how much gas did that cost me, the whole thing. So there was two transactions. There was the contract creation and there was the transaction, right? So contract creation, and I know this is the tokens that it cost me, but gas is different, gas usage. So this is the gas usage and limit by transaction. This would have been the limit, I see. So, okay, so we know this cost 250,000 gas creation of the contract. So I think it's time to split my screen here. Okay, so estimated gas. Okay, so contract creation. Where do I put this? Maybe I put it in Figma. It's just some notes. Okay, so contract creation was 255,000 gas, almost 200. So, and then this contract call here. So that's writing a number. I think this was a byte or so, 6,500. So let me look at the code here. Yeah, this is like a uint 265. So that's 256. So that's 256. What is this? bits? Or is it an integer 256? Is it a byte? 8, 6? Whatever. Will be a byte, I guess. Okay. Yeah. Okay, so I wanna have a. How does a string work? Okay, it's basics. How do strings work in Solidity? Good. So, okay, it's just a string. And then I know that they are handled depending on their length. So then I would say this is a string text. And this is store num. And I don't care about, but retrieve num. And then function store text string new text public text is new text. What's wrong here? Data location must be memory or call data for parameter and function, but none was given. What? Data location must be memory or call data for parameter and function, but none was given. I don't know what this means. What? So I guess memory or call data, is it where it is coming from or where it is going to? You need to specify the data location for a string parameter at memory or call data of the type. Why is it required? Strings are reference types in Solidity, fair. So you must explicitly tell the compiler where the data leaves memory, temporary data that exists during function execution. This is when you might modify the parameter or store it. Okay, call that read only. I see. Okay, so it's const. I see. My friend, this is modify a parameter or store it. So then for public functions, use memory. Yeah, because I want to keep it. For external functions, call data is more gas efficient if you're not modifying. So it's a little bit like const, but not really external function. What is an external function in this context? I guess it's a function is called by another smart contract. So memory is the right choice. Is visibility modifier in Solidity? That means the function can only be called from outside the contract, not from within the contract. Interesting. External, public, internal, and private. Okay, this is an interesting modifier. So I've been aware of private, and internal can only be in the contract, and derived contracts. Okay, so private is really private. Internal is from all derived contracts. Interesting. What is a derived contract? Because it could be an inheriting contract, but I don't think so. Or it be a contract that is created by this contract. External. Makes sense. But this is interesting, can only be called external. I have not seen that before. And then a public can be called internally and externally. Interesting. So can be called from outside the contract or inside the contract. Only unless you use this external function, which is expensive. More, I guess I will need a primer on gas efficiency. More gas efficient, especially with larger array string parameters. Why is external more gas efficient? When you use external with call data, Solidity can read the data directly from the transaction without copying it into memory first. Interesting, making it cheaper. It's meant to be called by users. I use external with call data for better gas usage. Okay, so but then memory, why did it suggest memory then? Why do you, why did you say then that memory is better in my use case? My intention is to let the user call this function. What is the derived contract? The derived contract is a contract that inherits from another contract. Okay, so it's inheritance. Good. How do we inherit? Is interface. Okay. And yeah, are there abstract interfaces in Solidity? Why is external more gas efficient? Gas efficiency comes from how Solidity handles function parameters differently. For external versus public functions, data copying, external functions can read parameters directly from call data, the transaction data, without copying. Okay. It just reads, it doesn't copy the entire array. Okay. Public functions must copy parameters to memory because they need to support internal calls. Okay. Interesting. Why is it? So why do internal calls need to copy? Why do internal calls need to copy memory? Public functions must copy memory because they need to support internal calls. Why public functions need copying? Externally, internally from another data comes from memory. Data comes from call data. Call data must copy call data to memory for public functions. Okay. We have some numbers here, actually. 1,000 to 5,000 extra gas. So public reads directly from call data. If it's external, you can say call data and it's cheaper. If it's use external with call data. I gave you conflicting advice. You're absolutely right. User calling this function, you don't need to call it internally from other functions in your contract. Then external call data is actually a better choice. Thank you. So then we say call data. I had the public keyword here. So, but then I see. So if I don't use it in public, then I can use this. I see. As addressed memory because you saw the public keyword. When to use each. External call data public. Yes, Solidity has abstract interfaces with the interface keyword, and then we just don't have a implementation. Very good. Okay. Why do internal calls need to copy memory? Call data only exists for external calls. So call data is a special data location that only exists during external function calls. It's literally the input data from the transaction. When code executes internally within a contract, there is no call data. Internal calls work with memory. When you call a function internally, you're passing data that's already in the EVM's memory or storage. Yeah, so why is it more expensive? Data in memory. Public. Why external functions can use call data? External functions can never be called internally. I still don't get why internal memory usage is more expensive. Shouldn't it be cheaper because it already has the data loaded? With newfound clarity. Okay, so Claude doesn't seem to be too confident when it comes to Solidity explanations. What? Call data stays in call data. I see. You just told me the opposite. Wow, this is weird, Claude. You're telling me weird stuff. Okay. So this should be cheap. And then I want to have a getter. So same signature, retrieve text. And this is a public view. Explain the view. Explain the view keyword. View returns, and this is a string, and we want to return the text. Returns string. Ooh, so this is it memory now? Function modifier that promises the function won't modify the blockchain state, it only reads data. Okay, so it's like a getter. It's an indicator for a getter. Read, and I guess process stuff, etc., etc. Call out of view a pure function. What is a pure function? What is a pure function? Okay. Pure only uses input parameters. Ooh, pure function. Good. I see. Like inline. No, not inline. Yeah, okay. Good. So then let's talk about this error here and why it asks for data location must be memory call data memory. But now it's unhappy. Expected type name. It's string memory. Okay. And I guess call data won't work here. I guess that would be wrong. Yep. Good. So then, okay, then let me store this and compile it and deploy it. Okay, I can unpin the old one. The new one was created and it's the 16847. I mean, I guess it's this one, but transaction hash, block hash, contract address 48. Okay, and then how can I yeah. So okay, I guess this is initialized as empty and not as null. Okay, so let me store a text. And this is just a space, and I want to see how expensive this is. So I will copy the address here. And by the way, I'm gonna copy the URL to the Block Explorer and put it in my Figma. Talk with chains, smart contracts. So this goes into the smart contract section here. And this is my Block Explorer. How do we call this? Block Scout. Good. So this is our contract. This is the transaction here. And first of all, I want to see, did the contract creation cost the same? Now it costs more now. It costs a bit more. So, okay, so contract creation with uint. So this is a uint 256 field plus 2 functions. Plus setter getter, and then contract creation with uint 256 and string plus getter setter. So, and here we are at 1.6 million, guys. Okay. Okay. Would have expected, I was naively thinking it did cost the same. So that's 7,000 gas writing a short string. So that's 7,000. And then, okay, let's play around a bit with the length of the string. Okay, let's write 10 bytes or 10 characters and see what's going on. and then, so that's coming in, and then let's write 100 bytes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that's 100 characters. Okay, so that was 3,000 gas. Maybe because on the first call we instantiated it. People should learn Web3 AI will be saturated soon. Thank you very much, my friend, for your comment. Okay, I see that a few people are actually tuned into the channel. So yeah, feel free to let me know your questions or whatever your thoughts are. So where was I? Okay, so first call, writing a short string, writing 10 jars. That was 3,000. That was 3K gas now. And then writing 100 jars. $21,000 gas. And how much pass was it? 0.02 pass. So I guess the other one. The other one was 0.03 pass queued. 0.03. Now I wonder how much this is going to be on Kusama, but we will see soon because smart contracts are coming to Kusama. Okay, then let's see what 1,000 characters are. So I'm copying this. Copy. So 100, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 1,000 characters. Writing 1,000 characters. So this is 135K. And we are paying 0.14 pass. So what's the overhead here? The overhead seems to be, is the overhead maybe 3K? Let me just write 0, and let's see what happens. Do I get a refund? I should also check out what happens if I just store the same thing 2 times in a row. Can I go back? Yeah. So let me store this actually 2 times in a row. Did I overwhelm this system now? No. Okay, so 2 times in a row. So 135. So this one was 30,000. This is a little bit weird. Writing 1 character, 13K. And it's 0.01 pass. Okay, that checks out. And then 18,000. So this was again 1,000 characters, and it's 18K. And then this one, 18K. So it was just the first time. It was the first time I was writing to it. Maybe it is reserving storage, and so there's a baseline cost associated with how much storage there already is. Okay, let me just store the same thing one more time and expecting it's costing 18,000 again. And then let me store 0 2 times in a row. And then I'm done, I think, with my text experiments. Give me a primer on gas cost for different types, especially strings. Okay, we're still waiting for the transaction to go in. But okay, what's going on? What are we waiting for? Is the chain down? Did I break the chain? I'm actually not seeing blocks. Did the chain break? Did I break the chain? Was I writing too many strings? Is this the reason why people are warning me that I shouldn't write strings to the blockchain because it can handle? Ooh, there was a block coming in. It was just like down for a bit. What is actually going on? Okay, I saw one confirmation window just on the side. Now this is good. This is working. It just was not producing blocks for a bit. That was awkward. That was awkward. Just not producing blocks for a bit. Okay, so what do we have here? So I think this was 3,000. What did I do? Keep forgetting what I was doing. 3,000. Hey. Okay, I forgot what I did. Now the last two ones were. Yeah, I think this one was basically calling with the same. Wait. Yeah, so this one just executed, and there was 18,000, and I think it was. Was it this one more time? I'm not sure. I think I called it a third time. Maybe it's late in the evening. And so the last two were just calling it with 0 2 times. Okay. So I guess it's cheaper the first time. It's more expensive the first time I do it. And then every follow-up. And then here suddenly it was. So I guess when I'm changing the storage layout, guess it's like increasing or decreasing the storage. And if I'm changing the storage layout, no matter if I'm growing it or shrinking it, I might be paying. Okay, there's my transaction, and it's 3,000. So not really clear to me, like what's the pattern here? It seems like, yeah, so I'm paying 10,000 when I'm shrinking the storage layout. First time I was, so first call, I paid 7,000. And then the second time I was roughly in the same region, I paid 3,000. Okay. Okay, let's see what Claude has to tell me. So EVM charges gas primarily for storage operations. Reading and computation are relatively cheap. Okay, so we have fixed size types. They are cheap. So yeah, it's 32 bytes. And address is 20 bytes. Padded to 32. Bool is 1 byte, padded to 32, of course it is. And bytes 32 is 32 bytes, nice. And then uint8 is still 32 bytes, and uint128 is still 32 bytes. Okay, so everything is 32 bytes. Everything is 32 bytes. You broke Jam. Yeah. Yeah, sorry, Dan. Nah, it was just, I don't know. It didn't, I think I didn't see any blocks coming in for almost a minute. But what is possible is maybe I don't know, it's a Paseo testnet, maybe a bunch of the collators were down and just didn't produce their block. I have the block explorer open right now, and I see that the blocks are coming in every 6 seconds, So I'm gonna have an I see one missed block, so maybe a collator is down, whatever. All right. Yeah. So okay, so I think I understand the storage layout now. And how affordable is it to write? How affordable is it to write messages? You know, okay, we're gonna amp it up one more time now. And I think I'm gonna write an array, and it's an array of strings. And then I can just see how much it costs to write a tweet every time. Let's do it like this. So like 280 characters. I think that could be fun. Okay, okay, but let's learn about gas cost. Slot packing gas optimization. You can save gas by packing multiple small variables into one 32-byte slot. Makes sense. They fit into one slot. So a slot is 20,000 gas. You know what? Let me check out what it costs to write the same number again, just to see that. So writing it for the first time should be, I think we saw 6,500. And then I'm gonna write it a second time and we see how much that costs. So first call, 6,700, good. And then the next one, 2,500. Yeah. So there is a cost associated with being the first to write. And I guess it might be the same here. Yeah. So this relayouting is costing. It says 20,000 gas here, which I don't get. I mean, it's maybe associated with contract creation. So strings, the expensive type. Strings are dynamically sized and cost significantly more. Hi, this is a much longer string. 23,000 gas. So maybe the gas cost is different in is gas cost different in different VMs, e.g. Ethereum EVM and Polkadot Revive Revon. Good. So okay, so strings. So okay, it's basically it counts how many 32-byte slots you need. So every 32 is it? So each character is a byte. So is it like ASCII? Are strings ASCII? Eight byte characters. Are they Unicode characters too? Okay. Good. Okay, so we have 32-byte slots. And that determines the gas. So first call was 7,000. And then each consecutive call is 3,000. So maybe there is like a 4K cost associated with 32 characters. Let me see. So this would be like adding like we have one slot with 32 and then we add 3 more slots. So let's say one slot is 4,000. Adding one slot is 4,000. So that would be 12,000 to add the string. You know what? Let me try this one more time here. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I would expect that on the first time it again costs like this, whatever, 21,000. And then on the second time we can again figure that one out. And then I think we get to an understanding of what the cost of a slot is. Okay, let's see. So I was just writing two numbers so we can also see about that. So the first time it was 6,700 again. And then the second time it was 2,500. And that's what I wrote down here. Yep. Good. And now we have the strings coming in. So it's 4,700. What is going on? 4,700 for 100 characters and 4,700 for 100 characters. Okay, so maybe this, I don't know what is going on. Writing 100 characters is suddenly, what is it, 4,007? 4,700. So, and that was 2 times in a row. So that's 4.7K. Maybe it is already reserved. Okay, that's odd, but whatever. It's sort of in that range. Arrays are also expensive. So the first element, and then each additional element is 23,000 gas. What? I see. Okay, let's find out about that. So I will add a string array. Call that to read memory operations 3 to 5 gas per word. Storage read, storage write. Yeah, okay, storage write. Okay, so the notion of a slot seems to be important for gas cost. So, okay, let's write the contract where we have an array of string. And this is messages. And then, so function add message, and I don't feel like we should do anything more. String call data message, and this is an external call. And so when we let me call this one time, and then we can also see what happens if we do something illegal. So create messages array, and that would be an external call. Let's call it reset. And then, so, I mean, we could put it in a constructor, but this is actually more fun. And we can maybe see if what happens when we release data. Can we set it to null? Null message array. Okay, so we want to set messages to null. Is this a thing? Does it exist? Expected primary expression. Does null exist? Can I set an array to null? Okay, I guess I need to finish reading this. Yeah, okay, so arrays push, we call it push, and it seems like it gets initialized, so maybe there is not we cannot really reset it, but okay. So then we just say numbers. So this would not be a legal notion then. Undeclared identifier. It's messages. It's messages. Yeah. Unable to deduce comma type. So it's maybe like this. Okay. But now that I have the right keyword, okay, now it's also not legal. So then maybe it's pop push. So we can how do for loop works here? Traditional. So it's and but it's an index, right? So it's so give me u and I 0 of I, then numbers dot length. No? Messages dot length. Okay, and then for each one we want to just pop it one time. Okay, so this is how we reset the array. Does it give me a refund? Okay, and then so this is messages.push, and I'm gonna push the message, right? And then maybe we have like a pop message, and it's empty. So for because it's just fun. Okay, so push add 10 numbers. I see, so we can add this multiple times. Memory versus storage versus call data. So public pure returns, external pure returns, permanent expensive. Okay, practical gas comparison. Store hash. Optimization strategies. Use bytes32 for fixed length text. Fixed length text. Wait, so okay, fixed length. I guess in the sense of it will not change in the future. Or because I guess a string also stores the length plus the data, and so if we know we are just within one slot, then we can use a bytes32. Yeah, that makes sense. So within one slot, you can use bytes32. Okay. Use events for large data. What? Can be retrieved from blockchain history, but not accessible from other contracts. Okay, very good. Lovely. Pack multiple small values. Good, we have that. Okay, and then we have gas cost. I guess it seems like it's different for ours, but okay, yeah, interesting to learn something like this. Occasionally you see those discussions on Twitter. Occasionally, very very seldom, but I would say when people in the Ethereum space, well, I think when Uniswap version 4, Uniswap X, I think it was when Uniswap version 4 landed, I saw like some of the developers bragging with how gas efficient it is and like really cheap. Good, so expensive versus optimized. String. So this is the expensive version. String. Optimized version. Bytes user data hash. Emit event for off-chain access. And you have a verified hash. Okay, yeah, okay, I see. The optimized version is cheaper. Is gas cost different in different VMs? Yes, it is significantly different. Oh, look. I mean, yeah. But it's not Poker VM, but okay. Word size, single-dimensional gas model, multi-dimensional resource model, interpret only, ref time, proof size, storage deposit. Yes, sir. Dynamic gas price, some contract call gas, whatever, gas left. Yeah, but that's true for Poker VM, my friend. I'm not sure if this is true for everything in Revive. Revive is multi-VM. Okay. Storage deposit. Refunded when storage is freed. Okay. Yeah, I just tried 30,000 gas equivalent. Yeah, it's even lower from what I've just been measuring. Specifying gas for cross. Okay. R strings ASCII 8-byte characters. Solidity strings are UTF-8 encoded, which means they support full Unicode, not just ASCII. 1 byte per character, variable length encoding, where characters can be 1 to 4 bytes. Yeah. I see. Oof. Byte string returns bytes, not characters. I mean, okay. To be careful. Good. So, okay, so emojis are actually expensive. So maybe I should create smart contract that is just about emojis, sending emojis. Emoji chain. Emoji-based smart contracts. I don't know what the idea is, but I want to write it down. And then in the future have an emoji-based. Where's social? Actually, where's social? Here. This sounds like a very stupid idea, but emoji-based. Whatever. Okay. Iterating over strings. First byte. You cannot iterate over characters directly. You iterate over bytes. Okay. Character counting is hard. You need to parse UTF-8. I will not parse that. maybe Claude can do that for me. String slicing is dangerous. You can't safely slice strings by index because you might cut. Yeah, okay. Yada yada, that's all the same. Use byte length for limit, blah, 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 blah. Does null exist? No, null does not exist in Solidity. Interesting. I was expecting it a bit from the previous examples. And because the types seem to be very strict, which makes sense. You want to be efficient on the memory layout. So 0 values, yeah. And you use delete to reset variables to their default. So but what is the default string? Empty string. Empty array. Okay, it makes sense. Sorry. delete. Ah, yeah. Let me delete message array. I want to see external delete messages. Okay. Erase and delete. Yeah. Memory arrays cannot be resized, and delete acts differently. Oh, wow. Keeps length. Wow. So to completely reset an array, do I have to pop all the values instead of calling delete? Checking for null equivalents. Oh, okay. Cute. Mappings, the special case. Mapping, what is a mapping? Cannot be deleted and don't have a concept of null entries. Mapping. Is it like a dictionary? Mapping, panic balances. That looks like a dictionary. Address, event, okay. It's a nice notation. Set balance for this user to this amount. Okay, at least we have proper dictionaries. Yeah, I mean, Solidity looks neat, I would say. Very straight. You want it to be focused on the task at hand. Doesn't get too fancy, but it looks like it gets the job done. Returns 0 if never set. So there is no exceptions, which sort of makes sense. So we have to assume that we get 0 values, which I think this was when I was building in Objective-C, that was also always the case. It's just a different way of thinking about error handling. In a way, exceptions are more reliable. But a little bit harsher. And if you work with 0 values, the applications tend to sort of handle it better when you like miss doing a proper check, but also you're not really warned. So weird things can happen. I guess this is also, I don't know if this is a source of exploits, but yeah. There's no way to check if a key was ever set versus set to 0. You need a separate tracking mechanism. Okay. Optional values pattern. Since there's no null, you often use a struct with a Boolean flag. Okay. Okay, and we have structs. We have everything we need. It's cute. It's cute. Cute language. I think we can work with that actually. Dynamic array operations. Push. Clear popping. Delete. Gas refund. Sets. But so here it says sets length to 0, but I'm not trusting you anymore, Cloud. Because you just told me the opposite of that previously. While, okay. Could also do that, but maybe not check length every time, but it should actually be efficient in this case. But okay. Remove specific element expensive. Oh. Wow. And I guess linked lists are also not an alternative. Wow. Okay. Like working with lists is not really fun in blockchain development. Why? Like, and would we have a better situation if we used Rust for that? Okay. So yeah, it's we push and we pop. It's a stack. Swap with last element. I want to enter my live studio right now and see what's happening over there for everyone who is watching from YouTube. I want to see how many of you are here. We actually have 8 concurrent viewers, so there's 8 people right now that are watching this coding stream. Say hi if you care. Would be really cool. Okay, so let me continue. Common patterns, check if initialized. Exists. Can't just check name or age. Exists, but this is only for structs. Is this only for structs? It's the flag. Okay. Reset, delete. String empty check. Okay, so then I would say what I will be interested in is after I delete it, I would be interested to see the length. So I want to write a function that is a purely external function, and I want to have the message array length. So I'm just going to check this from the other side. So I want to have the message array length, and this is a this is an external view that returns a uint with the whatever result. View just a uint, and it returns. Okay, so and I just want to, and this is a pure. Is it a pure? Is it pure? It's a pure function, and it returns messages dot length. It's not pure because it reads from the state. Okay, so it's a view. Good. And then pop messages dot pop. Sounds good to me. Sounds good to me. Okay, so then I can unpin this. I don't know if I need to store. Did it just compile automatically? I think it just compiled automatically. I can deploy the smart contract. Push it out. And our new contract. Hi, Giraffe. Hi, Arctic Talk. Hey, people. Good to have you. So, okay, I deployed this new smart contract with my new functions, and the new address is C2A2. C2A2, so it's this one. And okay. So first of all, I want to get the message array length, and it's 0. Okay, now if I call pop and there is nothing to pop, what happens? Gas estimation eroded with the following message. Error. The transaction execution will likely fail. Do you want to force in? Yes. Yes, please send the transaction. I want a failing transaction. Nice. Very nice. Okay, cool. It warns me when I send a failing transaction. So I guess it has some kind of internal transaction simulation. Okay. So this is our new contract, and let's see about the transactions. So contract creation, 3 million gas. 3 million gas. Yeah, it's getting expensive. It's getting expensive. So my transaction is still pending. Are we again not producing blocks? No, I see that actually blocks are coming in on the block explorer. Oh, whatever. It's pending. Is it because it is failing? Failed. Ah, yes, this looks very good. To avoid, so gas usage and limit. Okay, so I guess that was the gas amount it used, but it failed. Very good. Okay, so let me call delete and see if this is doing anything. But there is not a lot to delete, so after this will be successful. So first of all, I want to see how expensive it is to delete an empty array. 6,000. 6,000. And when I delete it one more time, I guess it should cost the same, except it gets initialized and then deleted. So let's see about that. And then I want to have the message array length. And the result was 0. Ah, you see, it's cheaper again. So it initializes the array on the first time it uses it. So let me ask about that. Does the first call to a field initialize it? I observe that it costs more on the first time to set something on a field. Even delete was costing more the first time the field was ever used. Okay, previously I asked the question, to completely reset an array, do I have to pop all the values instead of calling delete? No, you don't need to pop all the values. Using delete on the array is actually the correct and more efficient way to completely reset it. Push, 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 delete, and it claims that the number will be, the length will be 0. So let's test it out. I want to really see if Claude is telling the truth here. So what I will do is I will add some messages. So this is message number 1. This is message number hello world. And then this is message number 2. So they should all cost the same because I think they all make up one slot. And then give me a message number 3, which is actually message number 4. Okay, so we made a few calls, and this one was the first one. And it initializes the array with 8,000. But it's already initialized, so we push with 8,000. We push another one with 8,000. So basically, we just push strings every time now. Yeah. So let me take a note here. So the first call here, 6,600. And then 2,400. So what we did was, so initialize the array with delete was like was something, I don't know, 6.5K, and then delete another time, and that was like 2.5K, right? So again, I'm getting this pattern that maybe a slot equals 4K. Yeah, because you also saw the pattern here. First call writing a short string 7K, and then the second time it was And then the second time it was 3K. Yeah. Writing one. So something here, maybe a bit more. And then deleting itself seems to cost 2,500 gas. So, and then pushing a short string, one slot, was 8K. So it's the cost of one slot and actually a string here cost me 8K, right? So it's roughly the same. It's a little bit more than writing a string, is adding it to the array, which might make sense. Okay, now how many times did I call this? 1, 2, 3, 4 times, I believe. Okay, and fee pass. Okay. Look, like the gas. Because the C is the same as the gas. You can read from this here how much gas was actually used, which is very nice. Thank you for that. So now let me pop one message, see what that does. And then we should be down from 4 to 3. And is it also possible to inspect the state? Contract creation code. Yeah, but the state. No. Should be a way to see the state, no? Contract. Transactions. Is there no way to see the state? Charts. Maybe I need to upload the contract code. Bytecode, contract creation code. But there should be a way to check this, or I guess it's after publishing. Okay, let me try to upload this because this would be interesting to me. Do we know the compiler? So, okay, whatever, no license. Solidity single file, and the compiler is 821 commit. Okay, that looks good. Default. Revive. Is revive a thing? Nee, default. And then optimization, I don't know. Okay, let me see. No contract could be verified. No. Maybe the version is different. Revive. So it's Sol JSON. I guess it's because the wrong EVM version. Meh. Add a custom compiler with URL. Yeah, but I guess it's written for. I see. Compilation details. Optimizer, yeah. Okay, so this is the first time I have an issue today. Because this is not cool. And is there an alternative way for me to, can I maybe upload the ABI? Optimization enabled, I don't know. Advanced configuration. EVM default, yeah. Okay, so this is maybe off. Does it work now? But I did not change the code, did I? Okay. It's a problem to solve for the future. So let's see how the popping worked. Pop 2,900. So, and is there a gas refund when I pop a string from an array? So, yeah, my question was, does the first call to a field initialize it? I observed that it costs more in the first time to set something in the field. Even delete was costing more the first time the field was ever used. Gas storage slot initialization cost. The VM charges different amounts based on the current state of the storage slot. First write, second write, third write. Okay. From unset to non-zero, I see, but wait, so to 0? Delete. But why is there a refund? I think you're hallucinating a lot today, Claude. Okay. First write is more expensive. You mean I initialize it, then I update it, then I delete it. Yeah, so even deleting sets it from an uninitialized state. So there is an uninitialized state to an initialized state. Yeah. Good. Yeah, okay. This is the pop question, right? So this is also, okay, there's no refund question. Is there a gas refund when I pop a string from an array? Yes, you do get gas refunds when popping strings from an array, because popping deletes the string data, which clears storage slots. The refund amounts depends on how much storage the string occupied. Okay, so there is a refund when I pop, but it's still costly. It's not like I get a free transaction, which would also be nice. I'm just saying. I'm freeing storage for you. Cost. Yeah, so if it costs 5,000 and I get a refund, it saves 10,000. So I could maybe, okay, so my transaction of just popping a string still cost me 2,300 gas. Is that because there always has to be a minimal cost? Can I calculate the gas savings of one function against another? Okay, example, push pop, bada bada ba. Important refund cap. Refunds are capped at 50% of gas used in a transaction. Okay, that answers one question. Yeah, and single strings and arrays of strings are similar. Good. Popping versus deleting. Yeah, we will see about that in a second. Both get refunds, but pop also reduces the array length. Okay. Complex strings example, push And then there is a message. So there's a struct. Okay. So a struct is also a thing that will have a, okay. Message queue. You see, you can make a message queue on chain. It's just that you can only pop from that, and it's memory strings, no refunds. You could maybe have like a rotating thing. Important. Memory arrays don't give refunds because they're not in storage. Yeah. Optimization tips. Batch pops in one transaction. Yeah, I mean, obviously, soft delete. Okay. So then the next thing I want to do is just call delete message array, which should swipe all of these things. I could have asked for a length. Is it too late? It's too late. Okay, 0. Okay, let's see how much deleting cost, and then I can just add a few more messages. So 1, 2, 3. So okay, so deleting the whole array actually did cost me 3,400 gas, but I would say that was fairly affordable. I'm getting message array length 0, which does not make sense to me. 3. Yeah, okay, so we have 3 now, and let me check what this was costing. So this was the freeing of the slot, 3,400, and then adding cost 3,900, 3,900, 3,900. So this it was cheaper, and now if I add another one, is a fourth one could actually also be cheap, but then the fifth one should be more expensive because previously we've been writing 4. So if we now write number 4 and it costs 3,900, and then we write number 5. Is it just 3,900 all the time? No, this one just passed. Okay, so 8,000. So it's not a true proper reset because this gives me the value of 5 now. But then if I delete the message array, it gives me 0. I have 4,000 cost, and if I add one message, okay, last thing here about this arrays, then I think we have arrays covered. 3,900. So it's sort of not completely freeing up the storage. Can I? I don't have a getter, and I cannot extend the contract. I have no getter for. I cannot read my own data. Do I have a getter? Maybe I built it. Messages. Can I not get all the messages? Can I not get all messages? 0. Okay, can I get message number 4? Execution reverted. Yeah, I think it reverted because it failed. Okay, so it's sort of, there is no reserved storage for that, but I still deleted it. Okay, I feel like this gives me a good understanding of how storage works, storage layout works. So Remix, we have deploying live. Now the question is, do I want to build a news or chat application? I mean, it's pretty free. It's pretty much free. It's one string is like 8,000, 4,000 gas. One string is 4,000 gas, 8,000 gas. Yeah, I don't know. Bro, how to print hello world. Bro, how to print hello world. On chain, we can print hello world on chain. Yeah, so I can print hello world on chain here in smart contracts. I can add this message to my nice message queue. But can we also, by the way, how do we emit gas used? It's a specific event. Data stored. Okay, so we can emit the hello world event. That would be fun. Let's do that. Oops. So storage. Okay, so I want to have an event, a hello world event, hello world, and we just give it a message. That is the message. Yeah, and so maybe we just, every time we add a message, we emit a hello world, and we give it the message. It's as easy as that. But maybe I just want to do the same thing. I just want to do the same thing without doing anything. It's not doing anything. What about pure? It cannot be pure if it is. So greet the world. So this function is called greet the world, and we give it this message, and then I'm gonna put this to the end here. So, and then we emit hello world with our message. Okay, so I want to compile this, and then I unpin this smart contract. This one is gone. I'm going to deploy the new smart contract. And then I have a smart contract that can actually read the world. Interesting. I'm getting a question here. It's not yet showing, but the question is, do you know how to reverse engineer? It's a very broad question. I do know how to reverse engineer, but you would have to be more specific with your question, what you mean by that. Okay, is my contract deployed? Contract address ECF2. ECF2 is always the lowermost contract. Okay, so I want to greet the world with hello, my dear people on YouTube and X. And I want to greet the world. So let's see what it costs to greet the world. What was it? Was it external? It was an external function with call data, cheapest possible way how we can emit messages, like reverse engineer apps. So, okay, so the question is, do you know how to reverse engineer apps? Yeah, let's go into that. Let's go into that. Did we publish our message? Contract call. Okay, how to reverse engineer? It depends on where does the application stay and what do you want to do with the app. If it's on your computer, it's an environment where you have a lot of control over stuff, and it's the easiest to reverse engineer it. If the application stays on another server, it's called hacking, typically. And then it's much harder to reverse engineer it because, first of all, it has to have some weaknesses that you can use to figure out what's going on. And yeah, if it's on your phone, it's sort of hard because a phone is a sort of a protected environment that doesn't want you to get in, but I guess it's still possible. But then you need to reverse engineer the phone first. And then it's a question of what you want to do. So the most basic thing is, in the end, a program is always just like very low level instructions, or sort of there is an intermediate level on which it's a set of instructions. So you can always look into an application and see what the instructions are doing. You have to understand what's going on, or what kind of intermediate language is it? Is it like assembly instructions? Is it, for example, Java bytecode or Solidity bytecode, right? So if we let me give you an example. This is the code that we're writing here to have our program, and it's understandable to us. But then if we look at the same code here on chain, so this is the deployed bytecode, right? So on the first view, this tells you nothing, right? What is this? This is a bunch of numbers. But what you have to understand is that in this case, is it EVM? I think it's EVM bytecode. So it's the Ethereum virtual machine is given this, and it's like an interface. It's like an agreed contract of what kind of data will it be able to understand. So the Remix application here that is compiling Solidity into bytecode knows exactly what the specified format is. And so this is a specified format that you find somewhere, EVM bytecode specification, or even like a decompiler. Did you see this? Like, let's try it out. Let's try it out. Let's reverse engineer our smart contract and see what's going on. So this is a decompiler. What it means is it understands the reverse of the interface. And if you give it the bytecode, let's see. It depends, does it match? Does the specification, is it the same version? But if we are lucky and the specification matches, then it will give you some version that might be readable to you, but what it will likely not know is the signatures. So retrieve num is something that is relevant for you as a human, but it's not relevant to the machine. So this gets replaced by an address. It's possible, like all the comments will be gone, all the variable names will be gone. So what you get is then something that looks semantically similar to this, but it will just make much less sense. So I don't know, function is a certain bytecode. Did we get a result? Book a demo. You're sure? Yeah. Okay. Not this one. Let's see if this page gives us something that works better. Bytecode decompile. If this is also trying to sell me something. Is this from RKX? Okay. Makes sense. Yeah. So sorry, I got a little bit dragged into the detail, but basically you compile it, and then there is a certain specification that tells it the bytecode. And bytecode is basically just a simplified format that is more compact, but the machine understands exactly what to do with that. Yeah. And you can reverse engineer that, but then it will be very hard because it will basically, in the end, this does not look like the reverse engineer stuff that you get looks very different and very ugly. It might, for example, you get something like this. Yeah. And so then you have just a bunch of characters and it tells you nothing. It does not tell you the logic, the story that is being told by the words that you're writing here. Yeah. So this is something that helps your human mind, but it can get stripped away because it's completely unnecessary for the machine. And so reverse engineering is one part, is sort of, this is the, you can get back to like roughly the instructions that were being given, and then you can maybe try to interpret meaning into that. And then you can begin to manipulate it by thinking, okay, if I inject this number or this string or this and that, how would the system behave? Or you could, once you understand what a certain function does, you could, for example, replace it with a different function. And then you can compile it again and run it again. But this is a very tough thing. So I think the most practical application that is also very motivating is how cracking the copy protection of computer games did work. So I guess it's still the same nowadays, but when I was going to school and we were leeching the pirated versions of games, there was always a competition between these cracking teams about how quickly they can get their hand on a game and then release it via torrent. And so the competition there basically was to reverse engineer and to do the smallest possible change to the game so that the copyright protection is basically overwhelmed. And once I remember I was reading this guide where you actually looked at the disassembly, and then for the simplest possible copyright protection, it's basically at some point it gives you a message box that says, sorry, but you're not eligible to play this. And I remember this for one game, it actually worked. And so I think it was a super lucky hit. But I was reading this tutorial that told you, look for that string of the message that tells you, sorry, you're not eligible to play the game. And wait, let me show my face. Where can I? And so I was looking for the string in the assembled, like in the assembly code, and sort of it was basically there was all the program code, which is assembly, which looks terribly ugly. Just so you get a feeling for how this looks like. Yeah, and this is with comments, right? So you don't get the comments, you just get like these instructions here. Yeah, this is assembly. But then at the beginning of the program, there was actually a table with all the constants and variables. And so I could disassemble that program, and then I found that, and then I found a reference, and it was a piece of, like, it was the address. And so I was checking for the address in the code, and then basically you got around to understand the instructions of, okay, this is a jump, and this is an if. And then basically at some point you're just replacing an if-else instruction. So if we find it's a correct version, we send the user this direction. If we find it's a legitimate version, we send the user in this direction. So either the user, you get a warning, or you get to play the game. And so it was just flipping this one instruction, this one if instruction, and you could overwhelm the mechanism. And I was doing this, and it actually worked, and it was insane. It was so cool because I could crack this one game, and then I could actually play this game for hours. So this was a really nice experience. This was a really nice experience. Yeah, but it's you just have to play around. So what do we have here? Hi, Ludovic. Yes, I'm having fun with Solidity today. Can I customize this thing? Chat is now, no, my face is now going here. Yeah, having fun with Solidity. Okay, let me summarize a little bit if you're just coming into the call. Yeah, learning Solidity, and I actually start to document my learning path. So in the first session, what I did is I learned how to do a storage contract. So the simple possible, like almost the hello world of smart contract. And I did learn how to run my own node. Today I started learning Remix, which is fun. And I was deploying live to a chain, and now I was thinking about what to do, and then we discussed reverse engineering. Thank you very much. Thank you very much. Do we know each other on Twitter, or did you just come by on YouTube here? Yeah, anyways, I want to do more. I want to do more live coding, and I just want to have fun and figure things out. I'm growing slightly tired, so I believe I'm not gonna do anything useful anymore today. Maybe we can just plan out my next learning path and what I will do for future sessions, and leave it at that. So I think I'm not okay. And so thinking about gas, and we understand gas. Understanding gas. Okay. Yeah, cool to have you. It's, yeah, as I said, I was just starting to learn, what is the session called? Live coding, smart contracts. Yeah. Just starting to learn Solidity, which is the most common programming language for smart contracts, so for programs on blockchain. Do you have a Discord? I don't have a Discord. I mean, if you have Telegram, if you, yeah, we can actually look into ERC20 and 721 a bit. If you have Telegram, you can reach out to me. I don't have a Discord. I don't know. Maybe if I do more of these sessions, I might do a Discord. But you can just subscribe and the bell thing and so on. Yeah, Ludovic, is it a suggestion from you, or you want to actually like look into this together? Because I would be keen to do it. I mean, we could quickly do our very first token, maybe, or mint an NFT would actually maybe more fun. But how about we do one token? We create one token, maybe a Ponzi. Let's call it Ponzi. Should we do a smart ERC20? I think they are. Let's see. No suggestion. Yeah, you know what? I'm getting tired, but maybe it's a good idea to do an ERC21. Maybe we can do an ERC 20 and a ERC 721, and launch our own Ponzi on. Yo. Yeah, okay, so let's look into that. I mean, we have the guides here. So deploy ERC20. Okay, so how does it work with ERC20s? So ERC20 is a standard on how to do tokens on Ethereum. So it has a very low number. It was one of the very first things, and it defined how do we do tokens. And the big advantage of having a defined standard is that every application knows how to talk with this standard. And if your smart contract conforms to this standard, it can be treated by other applications like a token. So you have this website where you find all the ERC standards, and some of them are accepted and some not. And basically it defines the interface. So it defines what are the public functions to read from the token contract and how to write to it, how to use it. And we can see it like Vitalik was participating in this, and this was 2015. What are you trying to make? I'm learning how to build smart contracts, and today we're covering a bunch of basics. So for like the last 1.5 hours or so, how long are we in the live stream? Oh, 2 hours 14. So for the last 2 hours, I was basically understanding how gas works, and we want to look into launching our first token and minting our first NFT, and then I'm done for today. It's Christmas tomorrow, and yeah, lots of things on the plan. But yeah, let's create our first token and mint an NFT, and then we are happy. Okay, so let's quickly review the standard, the ERC20 standard, and how tokens work in ERC. So I will just go forward very quickly. Okay, we have methods. So optional, it can have a publicly visible name. That's the name of the token. It can have a symbol, that's the ticker. Decimals. So we have it's a smart contract development. So it's a blockchain. It's crypto. It's crypto. Maybe I should make the title more explicit. It's cool. It's cool to have like random people stopping by. Typically, this channel is about Polkadot. But yeah, I guess since I have you people chiming in, feel free to come by. Yeah, so I'm just learning how to, like, I'm a developer by nature or by heart, but I'm just occasionally have been developing the last few years because I've been more focused on organizational development. But yeah, in my free time, I want to learn more about smart contract development, and that's where I'm at. So I'm sort of, let's say, I have a good understanding of software development, but a complete beginner when it comes to smart contracts and how you actually write programs on chain. And so this is where I'm coming from at the moment. Okay, so decimals is you represent the number of tokens you have up to a Planck, like the smallest possible unit, and then decimals tells you from that unit how many like digits do you have that are after the decimal and how many digits you have before the decimal. total supply, balance off, and then you can transfer from, I guess the user is calling the function, to the other address. Okay, so we'll deal with addresses. And then transfer from to. It's used for a withdrawal workflow. So this, I guess you allow another, so this is where approve and transfer comes from. So this is, you allow one smart contract to use the funds of another user. You're learning React? Nice. I don't know too much about React right now, but I have been vibe coding, of course, throughout the last 1.5 years. And occasionally when you, I think it was Claude or it was Cursor, I think Cursor. And I don't know what the backend LLM was. But when you tell it to build an app, it quite often builds a React app. And so I had to learn React when I was just presented by the code from the AI, and then I had to figure it out. And it's just like the hooks pattern in React, it's like not a new pattern, but the way it is used, it's used for all kinds of stuff. And it's used sort of, I don't know, but the way, like I'm very new to React, but the way it looked to me is that you can use hooks for all kinds of things. And so very often it does not have like a very strict notion of layers. Like there is not so much like a data layer and a presentation layer and a business logic layer like I was used when I was building software. It's much more fluid or flexible, I guess, because it has less strict nature and it's very easy to just come up with an application in React. But it also means you need to have a notion of the architecture you have in mind when you build a React application, because it does not prescribe it. But then whatever AI I was using, it was just throwing hooks like left and right. And then it was just becoming super weird, because then this one hook started using another hook and then another hook. And I don't know, like the AIs half a year ago, they were, or like 6-7 months ago, they were like much worse when it came to like when I use Cloud Code today, it's doing much better and maintaining consistency throughout an application. But half a year ago, it was much more messy. Okay, what comment do we have here? Vibe coding, do the work, but at least you gotta know the logic. Yeah, so this is super crucial, and this is like one thing I'm worried about. So I think it's awesome that so many people right now are able to learn how to code by just having that assistant come up with stuff and then they see it. And I'm sure, so at the moment, I'm preparing for a tech lead interview, I guess, I'm not sure. And it's just so good to have an LLM that you can have a discussion with that, because just the specific question you have, you can just bombard it with all the questions. And for that part, I'm using ChatGPT because it has folders. And when you put all the conversations around one topic in a folder, it references the other conversations. And it's really good, because when you just learn the concept and you're asking in another conversation for a new concept, because it knows all the other conversations you had on the topics and what you were recently learning, it can reference those things. And so it's really helpful in connecting the thing that you're currently learning with the things you've been previously learning. So for me, this is an insane experience, and I'm learning so fast right now because of this. And I can do the exercises on LeetCode over here. And just do the exercises here. And so the way I'm doing this right now is you have these like this is like data structures and algorithms section right now. So I'm doing these sections, and I can just approach them with a very simple and primitive and, let's say, childish mindset of, this is an interesting problem. I didn't have that before. So I'm approaching it, I'm writing down my solution, and then it's, I guess it sucks, right? So I run the solution, it sucks, I submit it, and it's sort of, I don't know, bad performance or like slow time profile. I think my memory profile is good, but my time profile is not so good. And so I'm trying to figure out, okay, what's wrong with my thinking here, or it just fails on some of the tests. And then I just go with that problem to ChatGPT or Claude, and it starts breaking it down in a way where it says, okay, this is the time complexity of your solution. And my time complexity was like n to the third power, which is bad, really bad. And then it says, like, this is typically considered the best solution. And I asked it, go through different types of solutions. And it says, like, this would be the naive approach, and this would be a slightly optimized approach, and this is a much better approach. And this is considered typically the best solution for this problem. And it has a time complexity of this and a space complexity of this, and yada, yada, yada. And so it shows me the supposed best solution, or the agreed best solution. And then I can just take this apart and I can ask questions about everything. And so yesterday I was spending 4 hours with the odd even jump here, because I put down my solution for, I don't know, half an hour. And I was very stressed because I was trying to simulate how would I react in an interview environment. And so I even stressed myself to the amount of being in that interview and having to finish this within, I don't know, 20 minutes or something. So I come up with a bad solution, and then I ask ChatGPT, and it gives me a really good solution. But this one was real, I don't know, I like to build stuff, but I don't have to, like, I have built fairly complex architectures in my life, but I didn't have to really engineer something to a very high degree where it's very optimized. And so these things at the moment are still a little bit intimidating to me. But then I look at the solution from ChatGPT, and I really, this has not happened in a very long time. I had to look at the solution for 1 hour minimum, or 1.5 hours. I'm not lying. And I had to look, I understood it sort of, but I had to then I broke it out into a Jupyter notebook, and I had to work on the Jupyter notebook and sort of go through each step just to like really go through the solution. So this was a real big mind twist yesterday. But it's really fun to learn this way when you use an AI LLM. Okay, what would you suggest me to do as a computer science student trying to learn the things to make a good career? I think it's different for different people. I tell you what has been working for me, which was, I like to pick a problem that really interests me. So for me specifically, this is building games. I love building games. I've been just building a game last weekend, or working on a game last weekend. That's fun. It's sort of also complex, but that's one thing that is really motivating. Another thing that might be motivating is you have a very tangible problem that you want to have solved. Like, I mean, I think the meta is changing with AI right now, because AI is just much smarter, or like much faster to help you. But you can build things for the fun of it, because you just want to understand them. So I think there is different layers. There is sort of the layer of coding the actual stuff, and you have to get practice with that. And then you can consult, and I think occasionally you can say, I'm not looking at whatever the AI gives me, I'm just going to try to solve this for myself. And I guess it's this important. But then, of course, talk with the AI, talk it through, like ask it all the kind of questions. And then there's different levels or layers of understanding. And I think what is important is that to get to these different layers. So what is the software design looking like, or the architecture of the program, or the system design? It's not super relevant in the beginning, but it's sort of the software design and software architecture. It helps over time to get a better understanding of that. I think everything that comes from a personal motivation is helpful, especially when you don't even have to build it yourself, but you have to try to understand, how does it work? So for example, how does a website work? Yeah. And then when you activate the developer mode, you can go into inspect. Yeah. And you can look at the document object model of the website. Yeah. And then you can begin to understand, okay, how does the document object model work? So does the HTML work? You can look into, how does the CSS work? You can look into, how does the JavaScript work? So you have these 3 components. you can go onto the net. Oh, I have to show my screen, sorry. So you go to a website, and there is the when you have developer mode activated, you go to the inspect tab, you see all the HTML here. You can, I don't know, you can do this stupid like beginner things of hello world. Yeah. Understand these things, then begin to understand how the style sheets work, then begin to understand how the JavaScript works. You can understand the network code, like reverse, I don't know, but the one thing I regularly reverse engineer in that sense is just understanding how does an API, like how does a website interact with an API. I don't know, let's open Figma here. Can I trick it to show the inspect tab somewhere? And then just see what's going on if I change this element. I guess it will have a WebSocket connection. Let me reload the page and see if what we see when we load the page. Yeah. But I'm pretty sure this will open a WebSocket connection because it's just constantly shuffling data back and forth, right? But then sort of just trying to get to understand how things work is really, really instructive. And I guess will be even more so in a time where LLMs just can take a lot of load away from you and in a way might make you lazy and just really writing code. So recently when I'm writing applications, it's not me writing application, I'm telling the AI to write application. But the thing is, what is important is you have an understanding of the software design and of the architecture. And so in a way, this requires thinking in hierarchies, like thinking about the hierarchy of how, so first of all, how does the program get initialized? So what's the flow through time? But then also what's the structure of how do you handle files and components and how do they relate to each other? So having these structural diagrams, I think is important. Because at the moment, still, this is something where the AI can get hung up on is the bigger the application grows, the harder time the AI has to keep it in context. Yeah. Okay, sorry if you know all that. It's just, yeah, I'm trying to like come to it one point, but yeah. AMPs to ask questions fine, but you shouldn't use it to write code at first when you're learning a language, or you will struggle to actually memorize and learn stuff. I agree with that. I agree with that. I think you have to find the right middle ground, right? You should not be too harsh on yourself, but it definitely makes sense to go through the pain of doing some of those things yourself. Good. So, okay, ERC20 interface. Transfer form approve. So you can actually approve and allow someone to spend tokens on your behalf. Allowance. And then events, transfer, and approval. That's it. Okay. So that's the ERC20 interface. And we have Open Zeppelin ERC20 contracts. So, okay, let's go to Remix. Let's put Remix here. Now let's put Remix here and let's put the guide here. Yeah, I'm not sure, Captain X, like how much that sort of, maybe it was too basic or something. It's just, I don't know you, so it's hard for me to judge the right level at which I should answer your question. Okay. So what do we have here? Open Zeppelin, they are providing these audited and sort of standardized smart contracts, set of interfaces, contracts, and utilities that are related to ERC. What happens when we open Remix and go to the start? ERC20, look at this, beautiful. Beautiful. ERC20. Oh, wow. Okay. Remix accounts. Remix tests. MyToken.sol. Wee. Okay, so is an ERC20 permit? I guess that's a different standard. So this is just importing and that's it. Can I just deploy this basic contract? My token, Ponzi. I want this token to be called Ponzi, and the ticker is Ponzi. The ticker is Ponzi. Ponzi. Is it that easy? Don't tell me it's that easy to launch a contract. Compile my token.sol. Ponzi, of course. Whatever. Compile. Deploy. That would be kind of pretty boring if it's that easy to deploy a token. I don't think we want it to be that easy to deploy a token. Oh, it failed. Creation of token error. Deploy. No, it failed. What is going on? The init size of this transaction is too large. Is the estimation wrong? Estimated gas is higher than the gas limit. It's okay. This is 3 million. Let's give it 10 million. Creation of Ponzi error occurred. The init code size of this transaction is too large. It is 82,000 while the max is 49,000. The init code size of this transaction is too large. It is cautiously increase the gas limit. Do I do this here? How do I, here, aggressive. Yeah, give it, it's 10 pass. Why is it not working? Oh man. Estimated gas. But estimated gas is also not working. Wow, I cannot deploy my Ponzi. How sad is that? How sad is that? Okay, then, guys, I think we'll leave it at that. We'll leave it at that, and I'm gonna end the session. This was a fun session, especially our conversation at the end. Why are you using naughty names? You mean Ponzi or what? What's up? What's up, Hope? Let's ask Claude about this. Okay, I am trying to deploy an ERC20 via Remix, and this is the error I get when deploying. Oops. So creation of Ponzi pending. Pretty sure Claude is not gonna approve of me trying to deploy a Ponzi. It did not have a not it. You have hit the contract init code size limit introduced in EIP 3860. The limit is 39,000 bytes, and your contract's deployment byte code is 82,000 bytes, way over. Enable the optimize. Is it not optimized? It's taking not a microsecond, but it's actually taking time now. I see. Optimization. This reduces bytecode by 30 to 50%. Is this actually something that I might have missed here by not reading the instructions? So let's see about the compilation. Okay, it does not suggest to use the optimization. So this is an issue. I will have to tell the team. Okay, let me deploy it now. Creation of Ponzi pending. Failed. And now it got even bigger. My optimization made it bigger. Only import what you actually need. This is what I imported. When I run the optimizer, it actually gets bigger, question mark. So what do we have here? The problem is ERC20 permit. It's deceptively heavy because it includes all of the cryptographic signature verification. That's adding 40 kilobytes of bytecode. Quick fix, change optimizer runs. Try optimizing the deployment size instead. Change runs to 1. I'm not trusting you, Claude. You're just telling me bullshit today. So, okay, so Hope was joining the show today, and first thing she hears is Ponzi. That's not good, Claire. That's not good. You should not go to a YouTube live stream that teaches you how to deploy your own Ponzi. Nah, it's failing again. Okay, so can I remove the permit? And then have just okay, let's try this here. Compile, deploy. Just remove the ERC20 permit. Yeah, it's just I'm confused that if this is the official Polkadot Remix tool, yeah, it worked. If this is the official Polkadot Remix tool, then why? Just why? Okay, so I guess we are launching our very first token, and there is no total supply. Yes, the total supply is 0. Decimals 18. Name Ponzi, symbol Ponzi. Okay, there is just nothing here. So I guess we need to mint. Okay, so let's check out what our guide is actually saying here. Yeah, ERC20. Look, they don't have it here. Okay, so this is an actual feedback we need to provide to the team. I wonder who I would feedback that to. But I think, yeah, I need a mint function. I guess I can put it in a constructor. So mint to, okay, can I put it to the message sender? So that would be message.sender. Is this how things work? Is this how things work? Ownable, initial owner, look, address initial owner. So address initial owner, minter, creator, it's the creator. And then ownable, I don't want it ownable, but I can mint it to the creator. Yeah, thank you. You think, let's see if it works like this, but it looks to be in line with what I'm reading here. And then the minter, so an owner can actually mint and burn, I see. Okay, let me see what if I can mint it like that, and then if that to the oops, what is the other? That's the amount. So is it in planks? I guess it's in planks, right? So I would actually like to have the decimals to be how do I define the decimals? Constructor name symbol. But what about the decimals? The decimals, I guess I can just override this and then it's different. Or is this like a convention to have 18 decimals? 12. I feel like 12 is a good number of decimals. Okay, so I want to have like, does it work like this? I give myself like 10. This is wrong. And it should not be virtual. 18 is a convention. Then we stay with 18 and I'm not gonna mess with the convention. And then I give myself one token, one full token. I think that is the right amount of tokens. It's the same ETH. It's nice for DeFi compatibility. Good to know. Thank you. Okay, I want to have one full token being minted, and there will only ever be one Ponzi. Can we, if you buy, like if it's a Ponzi token, it should actually give you interest on a claim. Okay, maybe not for today. But yeah, if we would go a little bit deeper, actually, like the Ponzi should give you interest in terms of future debt. That would be fun. Okay, so minting, transfer proof, yada yada yada. I don't have another. I guess it's okay, but I guess it will be too much for me today to go through the whole cycle of yeah, because I'm obviously getting too tired. I realize it. Why input required? Address of the creator. Oh, I need a creator address. So that's the address. So creator address. But this is fun. I don't know. Smart contract development actually looks fun. Feels very, I don't want to say simple. I think simple is the correct word still. I don't mean it in the sense of, well, let's say accessible. I would say simple in terms of it's just like it's a simple memory layout. It looks straightforward. I'm not sure if it has like the weird quirks like JavaScript has. But it looks like a language created just for the job. Okay, we have the contract deployed. Ponzi, total supply. Yeah. Okay, and then I want to have the balance of my account, and it's one Ponzi. And if I change it to whatever else, it is an error. Bad address checksum. Ooh, bad address checksum. So you can do address owner as message sender in a constructor if you, I see. So it's basically, I get the message sender for free. I see, okay. Yeah, okay. So is there like but this is compile, right? Okay, so compile, deploy. Okay, we're just spamming contracts now on the network. Thank you, Ludovic. Okay, yep. Good. Transfer. Can I transfer to myself? What happens if I transfer to myself? It needs multiple parameters. 2, and the value is just one blank. So I could actually override transfer now, and transfer always redirects a tax to the burn. Like there's always a burn. Yes, we're burning tokens now. So I can override transfer, give me the interface. So every time I call transfer, returns a success, return true. No, is it wrong? Is missing override specifier. Override. Where is the override? Struct modifier function override. Wrong position. How can I override a function? Public override returns. Okay, it's basically the only spot I didn't try, right? Thank you. Warning: state mutability can be restricted to pure. Okay, whatever. Okay, so how a transfer works is that it's from the sender, so I'm removing from the sender. So I guess I would have to do a sanity check. Chat is faster than I. So I would have to do a sanity check. So I would have to check if what's the field where the token where the balance lives? Balances? Is it balances? Symbol, total supply, account balances. It's private. Why is it private? There is an internal function that I can call, right? There is an internal function public. Public is also internally accessible. Transfer. So is it like, can I call this transfer or super transfer? Can I call this dot transfer or super dot transfer? Transfer, and it calls that looks like an internal or private function. Transfer from to, also public, and message sender. Okay, so this is like a transfer, and this is an internal function. So internal is not private, so it can be called from to. I see, and this is why there is different security checks on the internal function. So this is the one I would call, but I want to, and then it reverts. What is revert? Explain the revert keyword. Like, can I get can I catch this when calling from a derived implementation? So can I call this transfer super? Okay, so I can call super when I have inherited. Yeah. So my question was more, when the transaction reverts, does it just abort out of the whole thing, or is there sort of like it reverts completely? So it is basically like the function never was called, and I'm burning the gas, I guess. So I don't need to roll anything back. Okay, super. And this. Okay, makes sense. And then explain the revert. Stops execution immediately, rolls back all state changes, reverts. Okay, so everything is aborted. Yeah, good. So I can just call it, and since I think I guess I can trust that this function does all the security checks for me. Of course, if I were properly developing, I would be reading all the code that is behind it now. But is basically asking, is the to address, so why is the burn address an invalid receiver? Because I was just thinking maybe I send it to 0 to burn it. How do I burn tokens? Update from checks for overflow. Okay, I mean, this is why we have open Zeppelin contracts, because they sort of make sure there should be a burn function. There is a burn function. I see. I mean, okay, so there's just a bunch of exposed internal functions that I'm supposed to use. So then I could say burn message.sender amount times 0.05. Like, let's say there is a text so it's like there is no floating point numbers, but it needs the burnable extension. I see. So then this is let me just make a guess and see if that works. can I, and then do I need to have a constructor for this then? It's like this. Expected identifier, yeah. So the tax would be maybe like 5%, let's say, from 100%, or let's say in percent. How do I do floating point math on tokens, e.g. burn 5%? Do I like times 5, like, or is it, can I just do floating point math and then it rounds to the full number? Okay. So what happens with the rounding? How does how are the rounding rules? It always rounds down. Good to know. Always rounds down. So, but that means I should actually do the calculation like this. So, see. So, but it means that there is an amount, and the I need to calculate the burned amount. So this would be like it would be like uint to 5. Yeah, it's here. So there is the burn amount. So it basically says this because I don't want to have like rounding errors. I need to use basis points. Yeah. So you mean like I have the math here? So so the burn amount is then the value times the tax divided by 100. And I'm not going to make this configurable for now. And that means that then the remaining amount is the burn, is the value minus the burn amount. And then I would say that I burn, look, it imported this properly. I burn from the message sender, and I burn the burn amount. And then I transfer from the message sender to the to address, and it's the remaining amount. This is cool. And then this returns true. This is neat. This is cool. So there's always a 5% burn. So I can compile this. There's an error. Constructor, swoop is need a modifier base class. Can I just make this disappear? And then I need to see ERC20 burnable. Yes. And then I guess it complains now that I've removed this. No? Compiled? Compiled? Deploy. Creation of Ponzi pending. This is a fun session tonight. I think after this I'm gonna go to bed. But it's cool. Thank you, Dominic. Dominic, yes. Ludovic. Thank you, Ludovic. I'm tired. And tomorrow is Christmas. Did it? Didn't deploy it. No blocks. It's again stopping to produce. No, but it's interesting. The RPC is not showing the blocks here. or the block explorer, but on Polkadot.js, you see blocks coming in. This is different. I'm looking at Polkadot as setup. Paseo. Pet setup. Okay, wrong block explorer. Contract call. Why is it pending? Why is it not included? Hello, what's going on? Or is it already done? No. That took quite a lot of time, and there was blocks coming in all the time in the meantime. Why did no one want to include my contract? This is sad. This is sad. Okay, Ponzi, look. Oh, wow, because it conforms to a standard. Nice. So coin balance history. Okay, so no, don't worry, Ludwig. Okay, so I'm lazy. I don't want to make another account. I just want to transfer this to myself. So I'm going to transfer. I'm gonna steal the previous address. I'm gonna transfer to this address the total supply that exists. So I'm gonna transfer to myself. And I guess this should not be blocked. And it's even showing up in MetaMask. How crazy is that? You conform to an interface and the whole world understands you. And token transfer. Look, and tokens. Wow. 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 How cool is technology? How cool is technology? I burn tokens and it's showing up in the block explorer. You know, there will never be one full Ponzi. You will never be able to have one full Ponzi because there is only 0.95 Ponzi. I'm happy. I'm happy. I like transfer tokens and oh my god, this is so cool. I mean, maybe I guess I'm exaggerating a bit. I'm sorry for that, but this is so cool. Okay, so burnable. Okay. Very lovely session. Very lovely session, and this is where we're ending it. This is where we're ending it. So I guess putting this like this. Everything needs to be neat. And then we will see what's happening next time. Wow, this was so cool. I'm a happy man. I did not expect. I mean, it's maybe it is naive not to have this expected, but you conform to this standard, and then it just shows it in the UI. Maybe it's I don't know. It doesn't happen very often that you have this kind of wow effect, where so many people already did the work, and then you are building on top of that, and you just, because this is just like so many people must have put in work so that this can just work out of the box. That was fun. All right, I'm gonna pack it up. Thank you, Ludovic, for chiming in, and I hope you have fun in World of Warcraft, and I hope you have Merry Christmas, and we see each other next year. So I'm checking out, and maybe, I don't know, maybe I'm gonna do more sessions in the next few days. Let's see. I'm not gonna put too much pressure on myself, but this is fun. All right. Okay, I will check out. Yeah. Have a Merry Christmas. Bye-bye.